Mhm.
Okay. Maybe I will
Okay.
just take a couple of words, Artyom, and then
Yeah,
we
of
can go.
course, of course.
Okay. So, hi everyone. It's like I'm really happy to be with you as a vice president of IIBA Georgia chapter. It's really honor. And just want to say a couple of words about IIBA Georgia chapter. Back then in September 2025, when we launched, our mission was kind of simple to make sure no business analyst in Georgia feels alone and feels they are working alone. So our main goal was to kind of help every BA in Georgia, help them grow. And that's why this was the idea to kind of improve business analysis in Georgia. And our main goal is to conduct sessions like this. And for this, I want to thank you to Exadel. Uh, it has been not a partner in name, but it has been really active. And thanks again. It really means a lot for us. And to move to our main topic, so today's topic is to tame UML diagrams. As you might know, it might be a little bit nightmare for some BAs. So the floor is your Artyom. So thanks.
Mm-hmm. So, hi everyone. My name is Artyom, and today we are going to talk about diagrams as code approaches. So, I'm so sorry about my joining without camera because today my router fights against me. So, after the presentation, I switched the camera, but now my choice is not to switch it because to provide you a high quality of connection and high quality of my message, of course. So,
Okay.
I'm sorry, before you go ahead, sorry, extremely sorry to stop you, but I also would like to say a few words from Exadel side because it's great opportunity for us and we're extremely happy to be involved with IIBA and to conduct such meetings. And it's great opportunity for our BAs, for BAs across the country and other locations as well. I see some people are attending from other locations as well. So I'd like to say thank you to IIBA and also say thanks to Exadel because they're giving us this kind of a chance to attend and learn more. And as you said, Tamar, these UMLs and diagrams in general are usually pain for BAs. So it's really, really great opportunity for all of us to learn more and understand more, and then we can use and grow all together. So thank you, Artyom, you and Exadel and IIBA as well.
Thanks, Artyom.
Sorry, thank you. Please go ahead.
Alex, any additional points before we start?
Sorry for stopping you again. Yeah, I'm done.
All right, let's go to business then. So, how to tame the UML is today's agenda. Uh, I'd like to start from a short self-presentation. I've been working at the intersection of business and system analysis for almost 9 years, but I started working with diagrams even earlier. At university, I really loved the course economic and math models, and after I was shown my first BPMN diagrams at my first real job, I knew that was love. Today, we'll talk about how familiar and well-known UML has been given a new life. We'll look at popular tools for diagrams as code and explore how diagrams should be written in code and how they definitely should not. Today, we will not revisit the rules of UML notation. nor will we dive into the specifics of the syntax of diagram coding languages. Our goal is to look at popular tools, compare them with each other, and fix in our mind best practices that will make your diagram clear and understandable regardless of the chosen tool. And I'd like to start with the obvious question. Why should we move from intuitive, familiar visual editors like Draw.io or Lucidchart to writing diagrams as code? After all, we are not developers, right? And the first reason is faster modeling. Diagrams as code speeds up the creation of architectural diagrams, especially in complex integration landscapes where manual drawing becomes time-consuming. Instead of dragging elements in a graphical editor, an analyst describes the system structure in text, which is much faster to edit and scale. Additional acceleration comes from AI assistants that help generate diagram drafts, detect connection issues, and suggest common architectural patterns as well. While very simple diagrams with just a few blocks may indeed be quicker to sketch manually, such cases are rare in real world. Most enterprise systems include dozens of services, queues, APIs, and integrations, and so on and so forth, where the as-code approach provides clear advantages through reuse diagram elements. The second reason is maintenance. Diagrams as code significantly simplifies keeping architecture diagram up to date as the system evolves. When the code is well structured and properly commented, the necessary fragment of a diagram can be quickly located and modified without manually searching for elements on a large canvas. This approach makes changes more transparent and manageable for the entire team. As a result, diagrams as code turns diagram maintenance from an occasional task into a natural part of the development process. The third one is vendor neutrality. Diagrams as code reduces dependence on specific vendors and visualization tools. Diagrams are stored in a text-based format that can be edited and processed with different tools, rather than being locked into a single platform. This makes it easier to transfer diagrams between systems and teams without losing their structure or logic. If a tool or technology stack changes, migration is faster because the core of the diagrams already exists in a portable universal code form. This approach also lowers the risks associated with services shutdowns or changes in vendor licensing policies. Overall, diagram as code makes architectural documentation more resilient and adaptable in the long term. The fourth one, the bonus one, I'd say, it's storage efficient. So, diagrams as code takes up significantly less space in cloud storage compared to graphical diagram files. Text-based architecture descriptions typically require only kilobytes, whereas images formats can be many times larger. This becomes especially important in large projects where the number of diagrams grows over time. In that regard, diagrams as code helps optimize cloud storage usage without sacrificing the informational value of the diagrams. There are already quite a lot of diagrams as code tools out there, so today I'd like to focus only on the options that are truly useful for us as business analysts. So today we'll only talk about free tools. Here I'd like to say Zen UML, please forgive us. Uh, Also, we are interested in tools that support sequence diagrams. Moreover, all my examples today will be based on sequence diagrams because I believe this is the type of diagram we, as analysts, work with most often. And the third point that we are interested in tools that are relatively easy to learn today. That's why we won't be looking at Python libraries at all. These free filters will help us stay focused on the most interesting option on the market right now. So here we go. Let's start with Mermaid. Mermaid is one of the most popular tools today, largely thanks to its broad accessibility in every sense of the word. So talking about strengths of Mermaid, Mermaid uses a very approachable pseudocode style that's great for quick proofs of concept and draft level diagrams. Mermaid works smoothly inside Markdown, and it's natively supported in platforms like GitHub, GitLab, and Azure DevOps. That means we can start creating diagrams with almost no extra setup. But for knowledge bases like Confluence, there are also specific plugins that add Mermaid support. And also, out of the box, diagrams look fairly polished without requiring much style and effort. Talking about weaknesses, when you need to describe sophisticated integrations with nested or deeply structured flows, Mermaid starts to struggle a bit. For example, it does not properly support representing nested calls and sequence diagrams and other specific details and cases. So there are almost no built-in tools to fine-tune readability. For instance, no real control over vertical spacing between elements, so they can look cramped. No proper alignment option for arrow labels and so on. As a result, larger diagrams can quickly become hard to read. Color theming can be tricky here. One small change can suddenly turn a clear diagram into something that looks like a carnival poster, and it's not ideal for professional documentation. And even with extensive documentation, there are cases where the written guidance doesn't fully match how renderer behaves. Maybe it just requires deeper mastery, but time is our most limited resource. Let's proceed with PlantUML, another fairly popular language for diagram coding, and in my view, it's a more versatile option. Uh, it's a very flexible tool, both in terms of functionality and visual capabilities. It's well suited for modeling complex integration scenarios. And also it's Confluence friendly, but you still need to find and install a proper plugin to render the code into diagrams inside the Confluence. Let's talk about weaknesses. First of all, it's very conservative in terms of visual style. Something like old versions of Windows in some views. Also, some default features go against classic UML conventions and can look a bit out of place. You often have to spend extra lines of code just to revert to more standard, familiar practices. And sometimes this tool feels too flexible because of the sheer number of additional features. This slows down learning and makes the documentation harder to digest. In my opinion, you can safely ignore about half of PlantUML's functionality, and your diagrams will actually become more readable because of it. As George Orwell once said, ignorance is strength. This option for today is D2. D2 is a relatively new diagram syscode language. It seems to me that its creators studied the competitors carefully and built a pretty strong alternative. The D2 feature set for sequence diagrams doesn't span dozens of pages, yet it provides everything needed to design complex integrations. Many useful things are configured by default. For example, there is no command for vertical spacing, but that's because spacing is already handled for you automatically, I mean. There are several calm professional color themes to choose from, no footers. Even Image Export is set up so that diagrams are saved with proper margins. From my perspective, it's very convenient. And talking about design, it is minimalist, but modern and easy to control. Talking about weaknesses, the main drawback here is D2's newness. It's still unclear how well it integrates with Confluence and other platforms. From conversations with the colleagues, it seems there are currently very few tools available for embedding D2 diagrams into documentation workflows for a moment. Unlike Mermaid and PlantUML, D2 syntax feels more geared toward people with programming experience rather than complete beginners. That said, this is mostly a matter of getting used to it. And also, there are a few configuration options I personally missed when I tried to perfect the visual style of diagrams. For example, more control over arrow labels and the ability to adjust the vertical positioning of activation boxes. Still, these limitations are not critical for me. So, I'm not going to answer the question of which of these languages is better. Each of you will answer it differently based on your experience, your preferences, the context of your project, and so on. A good high-quality diagram stands on three pillars. It can be created quickly, it can be updated quickly, and it's understandable to everyone, from a tech lead to a business stakeholder who just happened to walk by. So keep these 3 points in mind when making your choice. We started with the idea today that working with diagrams as code can be faster than using graphical tools, especially if you work with AI assistants. However, today we still can't fully delegate diagram creation to ML tools because they often make mistakes and tend to use the simplest possible syntax, which isn't always informative and can leave gaps in the logic. So I'd like to finish this presentation with a few practical tips that will help you create professional diagrams, both from scratch and when refining a draft generated by an AI assistant. I'll use PlantUML in the following examples, but most of the techniques also apply to Mermaid and D2 as well. Let's start with participants. Keep participant declarations simple. All three languages allow you to represent participants as databases, collections, entities, controls, and more. While these shapes may look expressive, they introduce an additional visual layer that many stakeholders do not actually interpret correctly. For example, most people won't understand the difference between a participant shape and an entity one anyway. Unless your team already shares a well-established visual language, it's usually better to declare all actors as simple participants. This keeps the diagram visually clean and shifts the focus to the flow of messages rather than the infrastructure behind each box. Spacing and padding. So use spacing and padding intentionally, not in every cases. Sequence diagrams are not posters where you must fit everything onto one screen. White space is not wasted space. It's a visual tool that helps separate logical steps and phases of interaction. Adding vertical spacing between logical blocks makes the scenario easier to scan and discuss. So if you have to choose between a taller diagram and a denser one, choose taller because scrolling anytime is cheaper than confusion. Let's hide footers. Footers repeat the participant labels that are already shown at the top of each lifeline by default in PlantUML and Mermaid. This duplication does not add any new information, but it does make the bottom of the diagram heavier and more cluttered. Since sequence diagrams are about understanding interactions, not decorating the page, it's better to remove any repeated structural elements that do not help explain the flow. Large diagrams will need scrolling anyway, whether up or down. On small diagrams, footers just feel like a relic. Improve clarity with activation bars and sub-activations. It's common for diagrams created by junior specialists or AI tools to omit activation bars. Activation bars show when a participant is actively performing work, not just sending or receiving a message. Without them, a sequence diagram can look like a simple linear chart, even when the actual behavior involves processing, waiting, or nested calls. Sub-activations are especially useful when one component orchestrates several internal or external operations. They help visualize call nesting and make it clear which operation happened within the context of a larger process. This becomes critical in asynchronous scenarios, such as message brokers, callbacks, or WebSockets, where participant may trigger work and then continue independently. Activation bars make it easier to see where the flow is blocking and where it is not. So clearly modeled activations often reveal logical gaps in the scenario itself, such as missing responses, unclear ownership of processing, or steps that were assumed but never explicitly shown. Create a diagram style guide to define rules of the game. Without a shared style guide, every diagram risks becoming a small piece of personal art. Even if each one is technically correct, differences in colors, naming, alignment, and structure make the overall documentation feel inconsistent and harder to navigate. A diagram style guide is not about visual perfection. It's about predictability. When readers know what certain colors, note styles, or grouping patterns mean, they can focus on the scenario instead of decoding the layout. Your guide can include practical rules such as how to name participants, how to split large diagrams, using dividers, for example, or nodes across, which RGB color codes are allowed for highlighting, and common patterns. Over time, this consistency lowers the entry barrier for new analysts and developers and makes your documentation easier to scale across teams and projects. And last but not the least tip for today is do not hesitate to split one huge diagram into two clear, focused ones. A sequence diagram is a communication tool. We know about it. It's not a proof that you have modeled every possible detail in one place. So when a diagram becomes too large, it overwhelms the reader's working memory and makes the discussion slower and less effective. So even though there are different ways to section a diagram, it's often better to create two or three smaller ones that are easier to read. A useful rule of thumb is one diagram, one main purpose. For example, one diagram can focus on the happy path, while another covers error handling or a concrete type of errors. So small focused diagrams are not only easier to read, but also easier to maintain. When their process changes, updating a targeted diagram is far less risky than editing a single massive one where everything is tightly packed together. So to wrap up, diagrams as code is not about code. It's about making technical context a living artifact, not a forgotten picture. And I think that's all from me for today. I'd like to add that I share a lot about diagramming on my page on LinkedIn, so you can also find interesting insights, discoveries, and opinions there about diagrams as code and beyond. Thank you very much for your attention, and I'll be happy to answer your questions, guys.
Thanks a lot, Artem. Guys, if you have any questions, you can ask or you can ping in the chat.
Should we raise a hand or something? Well, if I'm allowed to ask, first of all, thank you, Artem, for all the time and efforts. This was a wholesome presentation and a good overview of strong and weak points. I would like to ask regarding your and your colleagues' experience in terms of adapting this diagram as code approach to our current AI-driven reality. So, from my experience, presently, PlantUML is pretty much easy to explain to LLM, and currently they're mostly already ready to present something in PlantUML for you on demand. Maybe you have any kind of experience with a Mermaid in same conditions. What is easier to automate, and what code from the generated pool is easier to maintain from the site?
Okay, thank you, Anton, for your question. So, actually, from my experience, I didn't notice anything. I didn't notice any issues in terms of working with AI agents for creating Mermaid diagrams, D2 scripts, and etc. So, from my perspective, for example, ChatGPT works good with all these options, but anyway, I'm not a big fan of Mermaid, and in that regard, the most my practical experience based on working with PlantUML, and here. Uh, Here, I guess the rules of the game is the same. That yes, it's possible to delegate to AI agents, creating some drafts, creating some baselines, basic logic, happy path, for example. But then you should revise it few times to achieve to achieve a valuable artifact, you know.
I see. But what do you think about the idea of fetching the ready diagram back to the LLM in a code version? Why I'm asking this? Because in our community previously we had a chance to meet the idea of storing the requirements in Git systems
Mm-hmm.
uh, in order to make it easier for developers agents to fetch the requirements from here. And from such a perspective, it becomes a tricky thing because Mermaid is natively supported by Git. And in case
Mm-hmm.
we put the Mermaid diagram right into the Git, will it be easier for agents to fetch it from here? So you see how it goes vice versa.
From my opinion, it's a good opportunity to investigate, and moreover, I know that our guys in Exadel are investigating such opportunities right now. Not at this moment, but at this period, since the new year, I guess. And unfortunately, I have no any valuable insights to share here with you guys. But theoretically, the storing some diagrams as well as codes in GitLab, GitHub, wherever. So it's sounds like a next step of documentation approach, and I think that maybe in 1-2 years we will see how this approach will work. And for a moment, this one looks very promising.
Many thanks for your opinion. That's it from my side. I'm good with
Thank you
this.
one more time, Anton. Colleagues, feel free to ask anything.
Artyom, I have one question. Okay, maybe I was wondering because for example for some tools that you mentioned, I don't have like quite big experience with them. So maybe you tell us a little bit more about the advantages, a little bit more in specific kind of the projects, or share your practice which you find the best in your personal experience.
Okay, thank you, Kitavan. So my favorite tool from this three is PlantUML,
Mm-hmm.
but only only regarding to only regarding to sequence diagrams, because I noticed one crucial point that all these free tools, I mean Mermaid, PlantUML, and D2 as well, they are focused on their one, maybe two, maybe three types of UML diagrams, and put a lot effort to support better visualizing of these very few types of UML diagrams. And I think that PlantUML is very good in state charts, in sequences, and maybe sometimes in small use cases diagrams. Mermaid, I'm not a big fan of Mermaid because there are a lot of restrictions, there are a lot of buggy moments and scenarios. So anytime I just tested some concrete cases, compare them with PlantUML outputs with D2 ones, and every time PlantUML outputs looks more convenient and fitable for my concrete context. Talking about D2, I'm ready to switch to using D2, but as I mentioned in the presentation, for a moment I have no idea which concrete plugin I should install to Confluence to support these diagrams, because in terms of visibility, in terms of readability, D2 combines Mermaid modern style with functionality, functional flexibility of PlantUML, and in that regard, it must be a killer feature. But without any plugins which allow to work with D2 via Notion, via Azure DevOps, via Confluence, and other Jira tools. So without these plugins, without these connectors, D2 looks a little bit useless for a moment.
Mm-hmm. Okay, thank you. And one more question. Maybe you share with us some of the tricks, maybe for in order to get the perfect result prompt or something like that. Like if you have any kind of tricks, because sometimes not for this you mentioned tools, but like with the ChatGPT, sometimes I'm struggling with the correct prompt because like sometimes I request an apple and I as a response I have an orange because of not correct prompt. So if you could share any tricks or any valuable, suggestions how it could go with, for example, with your favorite tool.
Okay. Recently, I described one algorithm which I used while I'm working on my analyst portfolio, and I described it. I shared it via LinkedIn, but there is no problem to discuss it with you guys. So. Nothing special, no rocket science, just a step-by-step instruction how I worked on creating how many diagrams I created for my portfolio. Around 65 sequences for different scenarios, different integrations, and so on. So, and I worked in this manner. So the step number 0 was to work with reasoning, structure reasoning technique for AI assistance, and make a skeleton of future documentation for example, concrete API method. After that, I worked with filling information into the skeleton, and anytime I skipped the step of creating diagram, so to let assistant take as much context as he can as he can take into account. After that, I asked the AI agent to create just happy path without activations, just happy path scenario. Then I manually added a few common comments like hide footers, like align labels to the center. Then what else? Also, I reduce the number of participants because sometimes AI agents try to suggest using a lot of services instead of, for example, just to backend and database. And on diagrams, I guess that we can save our focus on some basic entities, basic participants. There, then after that, when I got clear happy path scenario, I just worked in Socratic method and asked for AI agent about potential points for idempotency, potential points for retrying, for some additional cases, for some tricky things led by some occasional errors and so on. And after that, I just revised this scope of information and decided which is convenient for this case, for this concrete integration, and which should not relevant for this concrete integration. And actually, that's it. As I mentioned, there is no some innovative here. There is no rocket science. Just I just saved this algorithm in a post like a reminder for myself, first of all.
Okay, thank you.
Hey, maybe I have one question, a really fast one. First, thank you for your presentation. And I have a question about creating the diagram without using any notation. Because hearing such presentations, I like thinking that everyone using these notations, BPML, BPMN, UML, and stuff like that, and everyone knows everything about it. But to be honest, 50% of time I just creating diagrams, not using any notation. What do you think about it? Am I alone there, or?
No, I'm also here, standing the same ground.
I'm also here, but let me partially agree, partially disagree with you because in my practice, I usually simplify the original notation. For example, I simplify a lot BPMN 2.0, I sometimes I simplify some things in UML. For example, when I work with UML use cases, I think there are a lot of stuff out of the box which we just make the diagram worse and less informative. The same for BPMN, but I guess that basic notation rules, it's a good baseline, and it's a common thing for majority participants, stakeholders on the market. And that's why, from my perspective, it's not a good point to totally ignore golden rules of some notation, because in that regard, you can block your following communication and make it less effective.
Okay, thank you.
But in the end of the day, it's first of all, it's a toolbox, right?
Yeah,
So
tools are tools anyway. It doesn't matter
yeah.
what notation you use. I agree.
As for me, this diagram as a code approach and the ways that Artem actually described how to work with these and make things less dependent from our decisions, from how we draw this stuff and make something more automatized, is a good way to avoid blank page syndrome. I don't know if many of you face it usually, but as far as I know, for many people, the hardest step is just to start scratching something, start drafting things. So this is also the way to go.
I agree. This is the hardest thing
Yeah.
to start.
Second, that it's a good point. It's a good point about the blank page syndrome. So hopefully I have no problems with it, but it's only my experience, and I know that there are a lot of guys who would prefer to start from something prepared by AI agent, for example. But we anytime we should remember that we are the boss, not the AI. We only we are.
Okay, colleagues, do you have any additional questions? Okay, I'll take this as no. So maybe we can wrap up this session. Artyom, thank you so much for your interesting workshop. And thanks all of you for joining and for your time. Thanks a lot.
Thank you, guys. See you.
Thank you. Thank you all.
Thank
Thank you
you.
so much.
Tom.
Goodbye.
Bye,
Have a nice
guys.
day.
Have a nice day.
Thank you very
Bye.
much. Bye.